It's important for you to be able to graph factored polynomials. Before we get into more complex ones, I want to look at one that you should be very familiar with of f of x equals x squared. And what you need to be able to do is describe end behavior. And by that, what I mean is, do the right side and the left side go up or down? In order to determine this, we know from previous classes that x squared is a parabola, and we know that the leading coefficient here is an understood 1. It's positive, so the right side goes up. And notice here the left side goes up as well, and that has to do with the degree being even. We would describe this if we look at as x increases or as x goes to infinity, f of x is going up, so it is also going to infinity. Secondly, if we look at x going to negative infinity, we see that f of x still goes up to positive infinity. So in both cases, y, or f of x, goes to positive infinity. To determine this in general, I've created a chart here for you. Always look at a sub n, which remember is the leading coefficient. And then once you've determined what the right side of the graph will do, up or down, then you can determine the left side based on the degree. So for example, if we have something like this, where a sub n is, say, a positive 3 and the degree is even, the a sub n tells us what the right side will do. And then if the degree is even, the left side will do the same thing. As x goes to infinity, f of x also goes to infinity. As x goes to negative infinity, f of x still goes to infinity. I'm not going to write the end behavior in terms of the infinities completely here. I will show you a chart here in a second that lists all of those. But another example, suppose we have a sub n is positive, but the degree is odd. So in this case, we know because a sub n is positive, the right side goes up, but because the degree is odd, the left side is going to do the opposite. If we move down to a sub n being negative, we'll take the same example, but we'll make a sub n negative. Now the right hand's going to go down. The degree is even, so the left side does the same thing. They both go down. If we switch a sub n to being odd, negative, and the degree to being odd, the right side's going to go down, but the degree is odd, so it's going to do the opposite and tend upward. I've summarized this for you in a chart that comes directly out of your text. Always look at your a sub n first. Once a sub n is positive, then you can use the even or odd degree. And make sure you understand this terminology in terms of how to explain whether it's going to infinity or negative infinity. Basically, x going to infinity means you're moving right. X going to negative infinity means you're moving left. F of x going to infinity means you're moving up. And f of x going to negative infinity means you're moving down. This comes in handy when we're trying to graph more complex functions, but we need to be able to add a little more detail to make our graphs more accurate. Your steps for sketching a more appropriate graph, better estimation, not necessarily completely exact still, is to determine the end behavior using the chart that we just looked at above. And then you want to determine the y-intercepts, which by definition are where x equals 0. And then you want to determine the x-intercepts, which we discussed in the last video, is where y, or the polynomial itself, equals 0. What we're looking at today, everything is already either factored or in factored form, or easily factored. So let's look here. First, determine our end behavior. Notice there are 3 x's that we would multiply together, and our leading coefficient will be negative since both of these are positive. So that tells us in general that the right side is going to go down. The degree is odd though, so the left side is going to go up. Our second step is we want to determine the y-intercepts. So we're going to plug in 0 for x, which gives us 0 times 2 times 0 plus 1 times 0 minus 2. Remember, 0 times anything is 0. So our y-intercept happens to be 0, 0. To determine our x-intercepts, we're going to set the entire equation equal to 0. And if you remember from the first part of pre-calculus, the zero product property tells us that if something is multiplied together and it equals 0, 1 or all of them must be 0. So we know that -0 equals 0. We know that 2x plus 1 equals 0. And we know that x minus 2 equals 0. This leads us to x being 0, which is the one we already have here. This leads to x being -1/2. So we can graph that point here at -1/2, 0. And this one leads us to x is 2. We know that the right side tends down from our generalization above, and we know the left side tends up. So we can therefore determine that our graph looks something like this. I want you to also to be able to go in the reverse direction. So if I give you a graph, for example, something like this, where it crosses at -2, -2 on the y-axis, 1 and 2 on the x-axis, with your end behavior being something like this. This tells us that we know the zeros to be 2, 0, right here, 1, 0, and -2, 0. We can adjust these to the factored form of x minus 2, x minus 1, and x plus 2. But we still have some a value that we don't necessarily know what it is. However, we do know that this equation also crosses the y-axis at -2. So we know that -2 is equal to a times x minus 2 times x minus 1 times x plus 2. But at that point, we know that x equals 0. So if I plug in 0 for each of these, I end up with -2 times -1 times 2, which leads us to 4a. When I divide both sides by 4, I get a equals -1/2. And so my final equation I can write as -1/2 x minus 2, x minus 1, x plus 2.